have sphere X that carries a charge of 4 times 10 to the minus 18 coulombs, while sphere Y has an axis of 30 electrons. Right, and the first question, 10.1, is saying let's calculate the magnitude of the charge on sphere Y. Let's calculate the magnitude of the charge on sphere Y. So let's gather our information and see which formula we can use, right? So we're given the number of electrons on sphere Y, right? And then another thing we know is the charge of an electron. Although it is not given to us in this question, it is a constant, minus 1.6 times 10 to the minus 19. So what are we looking for again? We're looking for the magnitude of the charge on sphere Y, right? So there's a formula that says that the number of electrons in a charge is equals to the charge of the sphere divided by the charge of an electron, right? So you can see here that we have the number of electrons, we have the charge of an electron. So now we're going to be able to find Q. So what is the number of electrons? We are told that we have 30 electrons in axis, right? And then Q, which is what we're looking for, divided by the charge of an electron, which is minus 1.6 times 10 to the minus 19. Now it's just a matter of cross multiplying. So we're going to get Q being equals to 30 multiplied by minus 1.6 times 10 to the minus 19. So the charge on sphere Y is equals to minus 4.8 times 10 to the minus 18 coulombs. Let's move to 10.2. So 10.2 is saying that the spheres are now released and they move towards each other. Give a reason why spheres X and Y move towards each other. So let's look at X. X is positive, as we can see right on our sketch. X is positive, and then on the other hand Y is negative, right? And then we know fully well that unlike charges attract, right? So the reason X and Y are gonna move towards each other, it is because unlike charges attract, right? If they were like charges, they were going to move away from each other because like charges repel. And then 10.3, the spheres are allowed to touch each other. After touching, they move away from each other. 10.3 says that let's state the principle of conservation of charge. So the total charge in an isolated system remains constant. The total charge in an isolated system remains constant. That is the definition of the conservation of charge, right? The total charge in an isolated system remains constant or conserved, right? And 10.4 says that let's calculate the charge on each sphere after they have separated. So the two spheres touch and then they separate. So we need the new charge after they've separated, right? We have a formula for that. It is Q new. So the new charge on the spheres will be equals to Q1 plus Q2 divided by 2. But what is Q1? We can take either X or Y as Q1, right? It doesn't really matter. So if we take X as Q1, we're going to have 4 times 10 to the minus 18. And then plus Q2, which is Y, right? The charge of Y is what we had to calculate ourselves. That is minus 4 times 10 to the minus 18 coulombs. And then everything divided by 2, right? And then if you go ahead and put that in your calculator, you're going to get a Q new of minus 4 times 10 to the minus 19 coulombs.